Hi, my name is Jod Vellerry Keiru and my supervisor is Dr. Zaida. Today I will be presenting about our project titled Microplastic Contamination in Commercial Table Salt from Kota Kinabalu, Sabah, Implication for Environmental Sustainability and Public Health. Now let's move on to the introduction of this project. Plastic pollution has become a dominant environmental issue, making up a large proportion of marine debris. As plastics degrade, they form microplastics, which can enter ecosystem through wastewater, runoff, and atmospheric transport. These particles have now been detected in many food items, including the table salt, meaning human exposure is possible through daily consumption. This study has three objectives, which is first to evaluate the abundance of microplastic contaminants in table salt brand salt in Kota Kinabalu, Sabah. Second is to determine the physical and chemical characteristic of microplastic found in table salts. And the third is to evaluate the microplastic exposure from salt consumption through estimated daily intake. For research methodology, first is the collection of 18 brands of table salt sample at local market. Next is the digestion of salt sample using hydrogen peroxide, and then the extraction of microplastic using vacuum filtration, which then the observation done using my digital microscope, and lastly the identification of polymer type using FTIR spectroscopy. Now let's move on to the key findings of the study. Starting with microplastic abundance, the results show that all salt brands contain microplastics, with levels ranging from approximately 7 to 58 particles per kilogram. Brand B1 had the highest level of microplastic, with abundance of 57.78 particles per kilogram, and the sample with the lowest abundance were brand B5, which was 6.67 particles per kilogram. This variation likely reflects differences in environmental conditions at production sites, as well as differences in processing, packaging, and storage practices. Moving on to particle size, the result shows that a total of 175 microplastic particles were identified. Out of these, 123 particles were smaller than 1 mm, 50 particles were between 1 and 5 mm, and only 2 particles were larger than 5 mm. This indicates a clear dominance of smaller particles in the samples. Such a pattern is expected because larger plastic debris gradually fragments through environmental weathering processes such as UV exposure and mechanical abrasions. In addition, processing steps during salt production, including grinding and refining, may further contribute to the higher proportion of smaller particles. In terms of the particle shape, the result shows that fragments were the most abundant, accounting for about 54.86% of the total particles, followed by fibers at 36.57%. Meanwhile, pellets contributed around 5.14%, and films were the least common at 3.43%. These findings indicate that fragments and fibers dominate the samples. This suggests that the most particles are secondary microplastic, formed from the breakdown of larger plastic items such as packaging materials and textile, while the smaller proportion of pellets and films likely represent primary microplastic originating from industrial sources. For the color characteristics, microplastics identified in this study included black, white, yellow, red, blue, and transparent particles. The images shown here are the representative micrographs taken using digital microscope for each color and shape observed in the salt sample. For the chemical characteristic, the FTIR spectra show that all microplastic particles in the salt, fragment, fiber, films, and pellets are mainly polyethylene terephthalate or PET. This polymer is widely used in plastic bottles, containers, and packaging. Its presence in the salt suggests contamination likely comes from the packaging materials, synthetic textile, or environmental sources during production and handling. For estimated daily intake in table salt, based on 3 contamination levels, the estimated intake ranges from 0.05 to 0.41 particles per day, equivalent to 18 to 149 particles per year. Even at the highest level, intake is less than 1 particle per day. Although this appears low, salt is consumed daily, so long-term cumulative exposure may occur. Additionally, microplastic can carry chemical pollutants and microbes, which raises potential health concerns. Therefore, salt contributes to overall microplastic exposure even if the amount is relatively small. In conclusion, the study detected microplastic in all 18 salt brands tested, mainly less than 1 mm of PET fragments from black plastic and textile via FTIR. Daily intake poses low but notable health risks like chemical toxicity, digestive issues, microbes, and respiratory harm to Malaysian adults. We urge better plastic management, filtration in product, and further health and environmental study. To address microplastic contamination, we recommend first is stronger plastic waste management for sustainable salt production and marine protection. Second, routine monitoring of microplastic in marine foods integrated into national safety frameworks. And third is better plastic controls, purification, and quality measures in the salt facilities for environmental and public health. Thank you for your attention.